Welcome to this explainer. Today, we're diving into something that has absolutely obsessed humanity for decades, the quest for anti-gravity. We're going to trace this wild journey from the fringe engineering attempts of the 1990s right up to a modern-day, multi-million-dollar experiment at CERN that is quite literally forcing us to rethink the universe. Part 1. The Quest for Anti-Gravity. Engineering the Impossible. So back in the 1990s, Dr. Eugene Podkletnov was relentlessly pursuing gravity control, and he drew international attention through 4 escalating experiments. It all started in stage 1 with a spinning, cryogenic superconducting disk. Podkletnov claimed that by spinning this specialized ceramic under very specific magnetic conditions, he observed a slight weight reduction. A subtle anomaly, sure, but man, it sparked a total obsession. He really escalated things from there. He went from just observing a broad weight reduction in step 1 to attempting direct, usable control. Step 2 shifted to a gravity impulse generator that acted like a physical blow, while step 3 tried to make this practical at room temperature. But step 4? Step 4 is the real kicker. He built a compact toroidal solenoid device that allegedly self-levitated for 15 to 20 seconds. Literally the ultimate sci-fi dream of an anti-gravity engine. Now, while these fringe engineering attempts absolutely captivated the public's imagination and stirred up plenty of controversy along the way, mainstream physicists were taking a totally different approach. They started wondering, maybe we don't need to build a complex machine to defy gravity at all. What if nature had already created an anti-gravity material? Part 2. The Antimatter Gravity Mystery, nature's anti-gravity candidate. So what actually is antimatter? Think of regular baryonic matter, the stuff making up you, me, the Earth, built from positive protons and negative electrons. Antimatter is basically regular matter's elusive mirror image. It has the exact same mass, but totally opposite fundamental properties, like negatively charged antiprotons and positive electrons that we call positrons. Because antimatter is this perfect inverted mirror image, theoretical models like the CPT gravity theory emerged. Proposed by Massimo Vallata, this theory basically suggested that if you reverse a particle's charge, its parity, meaning its spatial coordinates, and its time, you don't just get antimatter, you might actually invert its gravity. In plain English, while matter attracts matter, matter and antimatter might gravitationally repel each other. If this theory were true, it would literally be the holy grail of modern cosmology. Just think about the massive problems it solves. If antimatter repels regular matter, it perfectly explains why our universe is currently expanding faster and faster. We wouldn't even need to rely on that mysterious, unseen, dark energy that dominates all our current models. It also beautifully explains why the massive cosmic voids in space are so terribly empty, and why regular matter gathered together so rapidly to form galaxies. It all points to massive invisible islands of antimatter hiding in these voids, just pushing our universe apart. It's a gorgeous, elegant theory. But, well, physics demands proof. To know if these cosmic voids are actually filled with repulsive antimatter pushing our universe apart, we gotta bring this massive cosmic question down to Earth. We have to ask the simplest yet arguably most difficult question in experimental physics. If you dropped a chunk of antimatter right here on Earth, would it fall down towards the planet, or would it fall up, repelled by it? Part 3. Dropping antimatter at CERN, the Leaning Tower of Pisa experiment. To figure this out, the Alpha collaboration over at CERN spent 2 decades prepping what is essentially a modern-day Leaning Tower of Pisa experiment. Why did it take 20 years? One word: annihilation. The very second antimatter touches the regular matter of an experimental chamber, it violently blows up. The mass transforms entirely into energy. So to watch antimatter fall, you have to somehow hold it without ever actually touching it. The painstaking precision here is just wild. First, scientists combined antiprotons and positrons to create antihydrogen. Then, because plasmas are ridiculously hot, they had to miraculously cool these antiparticles down to 10 degrees Kelvin. That is barely above absolute zero. After that, they shaped them into needles, suspended them inside an invisible magnetic field, and finally, very slowly reduced the top and bottom magnetic fields, basically letting gravity take the steering wheel. Part 4. The results are in. Down goes antimatter. Okay, so after releasing the magnetic trap, scientists tracked exactly where the antihydrogen atoms went. Did they shoot up or did they fall down? Well, the results were absolutely definitive. When the fields were perfectly balanced to let gravity do its thing, 80% of the antihydrogen atoms annihilated right at the bottom of the trap. Yep, just like a cloud of regular, everyday hydrogen, the antimatter fell down. It didn't fall up, it didn't hover, it proved once and for all that Earth's gravity attracts antimatter exactly the same way it attracts regular matter. Einstein's theory of general relativity, which predicted they'd behave identically, was proven right once again.
Part 5. Reassessing dark energy, the cosmological fallout.
While CERN's results is a huge triumph for experimental physics, the cosmological fallout is, well, it's massive. Take the baryogenesis problem. The old theory comforted us by saying antimatter was repelled away during the Big Bang, but the new reality shows it gravitates normally. It didn't just fly away. And think about it, if antimatter falls down, it definitely cannot be the repulsive force in cosmic voids pushing the universe apart. We are quite literally right back to square one with dark energy.
But hey, science never stops, right? Theorists are already proposing some really fascinating workarounds. What if gravitational repulsion does exist, but it actually comes from an inverted space-time? Or maybe the true cosmic antimatter hiding out in those voids is fully reversed and repelled, but the tiny artificial amounts of antihydrogen we make in our labs are somehow forced to conform to our local downward gravity? They're even looking into models where cosmic repulsion happens between alternating islands of space entirely.
The quest for anti-gravity, whether it's engineered in a lab by mavericks like Podkitsnov or searched for in the fundamental building blocks of the universe at CERN, has constantly pushed the boundaries of what we know. But antimatter falls down. That door is closed, which leaves us with a final, kind of mind-bending question to take away from this explainer today. If antimatter isn't the anti-gravity engine hiding in the dark, pushing our expanding universe apart, what unseen force truly is? Thanks for joining me on this incredible journey through physics, and keep questioning the universe around you.